Hi everyone, I'm Thomas. I'm a product manager on the web platform team at Google, and I'm relatively new to the AI space, but have been working with WebAssembly and other teams for quite a while. And uh, today's session is going to be exploring challenges with cross-origin resource and model sharing. If any of you were in this room for Kenji's talk, this is 100% the part with lasers and sharks and lava that he was referring to, of trying to solve the general problem. I'll get into a bunch of details, but I do want to preface it by saying that you'll see some slides with code and like kind of other, what seems to be pretty far developed ideas, but this is still a very nascent space. And honestly, we're just trying to figure out if there even is a solution to some of these different sets of problems that are worth tackling. And so I'm hoping to like burn through all of this stuff pretty quickly and then get into a lot of discussion about some of the primary problems. I'll also note that like these slides and everything else was graciously provided by like Tom Steiner, Christian, and Francois that you see listed here. And I know Christian is on the call. So if at any point I say something incorrect or he has anything to add, I hope he jumps in. Okay, blasting through this, we covered a lot of this stuff, so I'll go through it very quickly, but different applications, web apps would like to have different AI models or just general resources like the React framework or the Flutter runtime, right? Large resources. And of course, if you have something like a large model, like the Whisper Small, that is 967 megabytes, you don't want to end up in a situation where two different applications like asr.example.com and speechtranslator.example.com are both caching these models locally. And of course, because we have hashes and we're very accustomed to caches and managing those caches through hashes and URLs, this is a pretty solvable part of the problem, at least, that we could leverage. And the way for developers to actually specify this stuff would happen at the framework level. And we can look at common AI inference libraries like Transformers.js today. This could also be WebLLM, MediaPipe, TensorFlow. But the mechanisms are generally the same across these. In Transformers.js, you create a pipeline. Sorry. You create a pipeline with the task that you're dealing with, like in this case, automatic speech recognition. So if the slides were back, you need to.
Sorry,
do I need to read mine?
I don't know.
Oh, I was kicked out?
Yeah, you got kicked out.
What? I swear I didn't.
I saw you not push it, so I believe you. I'll try not to have my feelings hurt too much.
All right.
Okay, let's try this one more time. Oh, no, that was the wrong one. Apologies, folks. We're back. So here you can see the transcriber equals await pipeline, where you can specify something relatively generic, like an automatic speech recognition. I think this also relates very much to some of the idea Kenji's was talking about with in terms of fungibility. Maybe you can describe a list of models that are more acceptable, but you can also specify very exact ones. So here you can see the default will use a known to work well for most common cases kind of model and pick that. You can see that stuff loading here. And then you can also get more specific, right? Like say, hey, I want this thing, but hey, if this thing is available, for example, I'd prefer to have that one. And so Transformers has all of this in there today, but of course it only works on a single origin caching level, and there's no cross-origin caching today. And one interesting aspect of this is that there are very large models like Whisper Small generally, and then there are more specific ones like English. An interesting aspect of this is that let's say you have a specific user who maybe just needs to translate things to English or only needs to transcribe English. You could serve just the English model to them, and that user would probably be more likely to visit other sites that also would need just the English version of that model. And so you don't have to be as general with some of these use cases. So two observations, URLs are great, right? This is kind of the solvable part of the problem, if you will, of just identifying resources through these different URLs. And of course, also hashes. And observation two is this fungibility aspect. Sometimes more than one resource gets the job done, and the developer is kind of fine with a fungible set of possibilities. So this gets us to the cross-origin storage, or for short, COS. It's an early design draft to address the challenges mentioned before. COS is a new cross-origin storage mechanism that is modeled closely after concepts introduced in the What Working Group file system standard, like file handle. And so again, you're going to see a lot of code, but like this is still very early days. But it could work largely like this, where you kind of have a handle that you await, and then you get a cross-origin storage request file handles, and Chrome would kind of take care of the storage mechanisms behind the scene. Storing the file is very similar, right? You basically pass this thing in and say create an entry. And so then if we go back to transformers.js, they could potentially explore polyfilling this. Obviously, you don't have the cross-origin aspect, which you couldn't polyfill, but they've already played with this. And if we basically, as someone was saying in the earlier sessions, like brought down the force field and moved back to a world that had single key caching, this would already work transparently today. We'll get into the reasons why that's not the case. I'm not sure how much of this we actually need to go through. Since again, this is like, if you want to look through the slides, this is how it would actually work in a very realistic example with transformers.js. And this, again, you can imagine specifying different models in a list of preferred kind of scenarios. So there are a lot of open questions, and I think this is where I'm hoping to spend the meat of our time together. The challenges involved, we already touched a little bit on, but I'll reiterate. Version fragmentation is probably the biggest problem. All the top 10 most loaded resources on the web are jQuery, but no one version has more than 10% of website reach, and that is the most common resource in the entire world. And so for a lot of these, you're talking sub 0.001% of origins that use some given resource that you might be talking about. Of course, when exploring this with other things, that principle extends to React, for example, or other frameworks where there's just so many different versions out there across the web. Leaking browser history is a huge privacy issue. The attack vector here is that if you know that a set of websites are using very specific models, you can try to load those models. And if it loads really quickly, you can presume that the user has been to those set of websites. I think it's worth pointing out that that's a much more severe problem than just creating a fingerprint, because it can leak the actual browsing history that you've been to, which has very relevant applications in terms of advertisements and like generally like proposing various products to you. And so has, I think, a much more substantial vector for abuse. Monarch making, aka king making, is a huge issue as well. This can come in two flavors depending on our solution. If we decided to just pick a set of frameworks or AI models that are like gold sealed and we would cache those, then we are literally picking the winners in this situation. But even if we based it on popularity of just taking like the top 100 most popular resources, you're still building in an intrinsic advantage for who happens to be winning right now in terms of popularity. And you could end up entrenching that particular point in time advantage. Bundler mangling is a huge issue, more for general resources than for models. Bundler mangling means that you obviously like push in your library and your bundler removes all the unnecessary part, but it makes it effectively impossible to actually discern out which are the possibly cross-origin shared pieces. This is much less of an issue for models, at least the way that it works today. So possible solutions that we've kind of talked about, and I'd love to dive into with various folks. One solution to the version fragmentation is some kind of long-term support style version pinning. You could maybe say, hey, React, please identify a major point release and communicate to your developers that this will be the cacheable version. And if your developers want to benefit from cacheability, they should make sure to pin to that specific version. We've already talked a little bit about fungibility, but especially in the AI model space, that's something where you can much more easily say, hey, here's a list of all the things that I'm willing to accept. And if none of them are on the list, then I'd like to go and fetch it. For the privacy and browsing history leaking problem, you could imagine some kind of random caching, where if you have a predefined list of all the cacheable resources, you could randomly pick some subset of them to load on a particular user's machine, even if they didn't visit a site that actually needed that, which would end up fuzzing the signal at least that you got from the version history. Major downside is, of course, that you end up with unnecessary modules on the device and expending more bandwidth cost, which can be very impactful for users. Whether this could also be made to be a little bit smarter, if they were able to, again, recognize that list of cacheable resources, they could put a reference rather than bundle mangling the entire thing in, and then on load detect whether or not they should go and actually fetch the model, ideally then also caching it appropriately. Also a note on shared broccoli. I know it's not broccoli, but that's what I see every time I look at the word. Shared broccoli is a pretty exciting new technology that enables basically like dictionary-based deltas, such that you end up only serving the parts to the actual specific client that isn't available locally, and you can understand what that delta is between a given resource that has maybe some subset of it available locally, and you end up just being able to load the delta. I don't understand all of the stuff involved here, but Patrick Beenan has been pushing this forward, and you can reach out and also check out go/pervasive. Apologies for the external folks who don't have access to that doc. So yeah, that's basically it. And I would love to hear thoughts on, like, is this a total pipe dream, Hail Mary, or is this something that we could actually see being kind of tractable? Are there solutions here that seem appealing to folks that they would like to explore more?
So governance is hard. I think Mozilla has some similar to prompt API, some extension only exposed. We trust these model stores. They seem trustworthy enough to, let an extension developer pick whatever they want. And do we think some of these privacy concerns would be mitigated if there was some kind of trustworthiness check of the models?
I think there's the trustworthiness check of the models might not be as relevant as the trustworthiness check of the website that is trying to load a particular model. You basically have to trust that. You basically have to trust that the website that is accessing which models are available locally is not doing so for malicious reasons. We have played around a lot with different trust models in general across the web. Something like leveraging the install signal has been explored a bunch of times, and there's a bunch of pros and cons. Obviously, a site that you install might still want to be malicious or to maliciously track your browsing history for nefarious purposes. But you could also put up a prompt of, like, would you like to expose, or can this website utilize models loaded by other websites, or utilize resources also used by other resources? And then you get into the, like, should we be explaining the privacy risks associated with that, which gets very hard very quickly. Okay.
In the LTS style version pinning idea, I don't know, like all the HTTP cache flags, but can you basically say, all right, cache this for a long time, but check, and if we do release a dot release, but we don't call it that, we just put it out on the same URL, that you will eventually check and download that?
I think in that case, we do reference the hash specifically, which would then be different for a given origin. But of course, we could design this any way we want it.
Right. I mean, then that sounds good to me, in that it should reduce the number. It should reduce the fragmentation in the long run.
Yeah, the fragmentation is still a problem in the sense of there are just so many frameworks and so many libraries as well. And for things like React, yes, if you get everyone to agree on one version of React, you'll probably get pretty big benefits. But the list of those extremely popular resources drops off very fast. And in terms of models, are basically non-existent today for, like, most models, right? I don't have numbers on this, but I would wager that there's no AI model that reaches more than 0.1% of origins or less.
How many resources would you expect a typical site to access, sort of maybe on average, and then in the worst case, right? I think is an interesting question.
Yeah, absolutely. And I can only guess myself, but 1 to 3. Probably
on average.
Yeah.
And are there these worst case use cases where it's like through the API we want to enable like accessing 20 or 50 or?
I don't see a specific case necessarily. Obviously, if you have some really large complex application that pulls in a bunch of different subsystems, you could do that. But I also don't think that's a failure case necessarily. Obviously, if there are 20 very, very large modules, that can be an issue. But I mean, 20 small modules is not, I think, meaningfully different than 20 times as large model
or
resource.
because I think from a privacy perspective, right, there are essentially two problems that you highlighted. One worse than the other, right? Essentially, we have the fingerprinting, which is not good, right? But maybe it can be sort of, there's a very small bit amount that we can like sort of put this down to, because we can say, okay, well, you can't have more than 3 requests. And then there's the actually leaking browsing history problem, which is worse. And I wonder if there are ways, and I guess you point to some ways that, right, like, to mitigate that in a way, to reduce it to certain publicly available libraries, or I think maybe just changing the threat model, like updating the threat model in a way that says, if you are broadcasting this information as a third-party site, maybe that is sort of something a risk you take.
Yeah, like you kind of accept that your resource could be utilized in that way, or like that's the expected contract.
Right. So I think depending, so I could just try to throw some things in here, like how to set
I appreciate that. It's hard.
So you mentioned hashes, and I think in the earlier session I was asking, are we focused on the storage or also the runtime execution? Do any of these, ML APIs, would they benefit from if a site says, hey, the model, and structure I would have used to say call WebNN or some model loader API, whatever it is, here's the hash I want to use. If you've already got it loaded up on another site and the graph would have been the same, everything else, can I just, dedupe even the runtime memory files?
Yeah, possible.
So like, are we coming at this at the right?
Brother, did you want to comment on that? Or?
No.
Okay. Yes, possibly. Are you also talking about like the possibility of for built-in APIs, perhaps handing off that model to user space or user land?
I mean, like even the closer to bring your own model, right? Like if I have 2 sites that are bringing the same llama model, and they both say, hey, I can download it, but I can also tell you the hash or some strong identifier for it.
Probably worth jumping in the cache storage API. If you load a WebAssembly module, we transparently, at least last I remembered, we transparently cache the compiled version of that.
We do.
So as long as you're pulling a single resource out of the cache storage API, you're getting that sort of behavior for free with WebAssembly. So it'd be interesting to see what are the analogies for if you're using this for AI models.
Yeah. I was talking to Austin, who was making a good point this morning about this would also be dependent most likely on the exact runtime that you're dealing with. So if you loaded an Onyx-based model, it would come in the Onyx format and only be compatible with the Onyx, obviously, runtime, versus something like a TensorFlow model. And that could end up similarly doing monarch making of burning in a winner with an established advantage. Kennedy.
Yeah, maybe that's a good way to segue to one of my concerns with the proposal is that the browser doesn't have much knowledge of what's going on because it's all a bunch of like hashes. And so if you focus on the AI models, it's very hard to understand whether or not you have some model that could definitely fit the bill, except that it's not matching any of the hash that are being passed.
Yeah, absolutely. And I think that's where this proposed solution puts a little bit more of that onus on the framework itself to say Chrome just deals in hashes, but the framework can let the developer decide here is the list of allowable models and can then look at what is actually available and has been cached to pick from one of those models. But I agree that potentially makes it harder to do magic on our part to reduce that complexity and can end up with a lot more fragmented models flying around.
And the other thing that it does, maybe there's like ways around that, but we get developers to like update to the new version of the framework, and the framework keeping use like hash sequence updated. Whereas if it was something we could get the metadata for through some other ways, we don't need to wait for the whole web to adopt the new thing.
Do you mean like a one-time update of the framework to basically let the framework understand the cache?
I think,
like, everyone would have to update transformers at least once, for sure.
The fact that the knowledge is within how you use the framework is a bit problematic because, like, it doesn't have to be this way. Like, if you look at maybe which version of this framework is compatible with like another version, like backward compatibility. If there was a way for us to know that
Right.
information by reaching out to some server, we could do a lot more with what we have.
Yeah, I think it is exactly that same point of like, where do you want that magic to live? Do you want that to live with us as Chrome and browser engineers, or do you trust the ecosystem and the frameworks to then actually try to manage that? And I would agree with you, it's probably better to have us manage the magic, because who doesn't love being a magician? But like, maybe there are some advantages to the framework approach as well.
Yeah, and when I say the browser managed logic, it has to be something the ecosystem takes part in, because I don't see ourselves maintaining like list of compatibilities and whatnot.
Yeah,
Right?
if I thought standards was hard, I can only imagine trying to get everyone to agree, like you said in your session, on what's the best model for this use case.
I think that actually kind of like segues well into the question I was going to ask, which is like, have we asked developers whether they would opt into some of these schemes where they are choosing a use case or a generic version of, say, like, I want, this model, I don't care what version, or I want this model, but at least like the version, version 3 or higher.
Yeah.
Like have we gotten signals that like they would be willing to make that trade-off? Because the experience I've gotten from developers in other areas is that the reason there are 10, there are, all the top 10 resources are all jQuery is that, well, that's the version they tested.
Yeah.
So that's the version they
It
want.
varies a lot, and it basically varies correlated to how large the assets are. When we talk to your average developer who's doing like React style applications, they don't really think about this stuff. I'm sure Alex Russell and others would have opinions about how much more they should be thinking about bundle size than they are. But the reality is that cross-origin caching is not very high on their list of priorities as an individual developers. When you talk to frameworks, it's more of interest, especially to folks when we talk to Flutter. They were extremely interested in this kind of functionality because their runtime is much larger.
Okay, but that's, sorry, when you say that like small developers aren't interested, you mean that it's like small developers don't care about their bundle size?
Yeah, basically.
Alex's whole
Yeah.
shtick. But framework vendors would want
Do care more.
Do we have like that specifically framework size, which I think the other sort of the point, like maybe to like my Kenji's presentation, is that like models are like 1 or 2 orders of magnitude larger than their sort of typical JavaScript framework. And so I'm curious if we've asked the question specifically when it's like, imagine you have a 200 megabyte resource. Does that change your behavior?
Yeah. I haven't asked that yet, at least.
Started to so the data that I shared earlier is like still partial. We are going to get a lot more responses. But some of the question in that survey were things like, do you value control over the model? And please explain why so. Or do you actually care about the feature itself and you don't really care about how it's done as long as the quality is good? And so far, I think it's mostly a split. It's probably like depends on what sort of use case you have in mind. And just looking at the open field reason that people have shared, some of it could be that they want a specific model because they know it's good for the specific domain they have in mind. So that could be one reason why they want something more specific than something that can do summarization. But I do feel so far that there's opportunity for us to provide that flexibility where we can tell there is a model that can do that use case. It's good for it. You could use that, or you could choose to download one more model if the user is okay with it.
I'll throw out the anecdote that the developers don't often complain to us, but they'll complain to, for example, Hugging Face. So our friends from Hugging Face who attend the Web Machine Learning Working Group meetings repeatedly bring up that they are being asked by the users of Hugging Face and Transformers.js, please solve this problem for us. And so Hugging Face then comes to us and says, as a framework browser folks, can you solve this?
And regarding the duplication, so we have a proposal of implementing a content addressable, so disk cache. So I think that the duplication of the disk and memory, so this is technically doable. So but duplicating the downloading, so networking part, so this is extremely hard for the privacy and security reasons. So yeah, that's one thing. And my question is, so I think you are assuming that we want to download this one without any user prompt silently. So that's why we are talking about all these technologies. So do you have any concern about if we do this silently, so we will end up downloading, for example, 1 gigabyte file or disk space silently? So do you have any concern around it?
Yeah, I mean, of course, users who magically see their disk space being filled up with random stuff that they didn't decide to install would probably be concerned. And I think we'd have to have a very good reason for doing that magically in the background, or we would have to have better user either notifications or like alerts about this happening, or explicit permissions, or more transparent storage management solutions. Thinking about like what UI users could use to manage on-device models is another rich space that we're just starting to think about.
I'm curious though, like when you hear from developers that they care about specific models, but hopefully you have to start paying the cost of serving that at scale. And also, you know, if we do decide to put UI in front of the user saying, hey, this thing is taking up this much space, right? That's might change the trade-off calculation.
Yeah, and of course, the relative size of these models ends up having a huge impact. You know, Flutter is a couple megabytes, depending on the application, and there are lots of useful AI models that are in that same range. Once you, and like users realistically do not care about a few, maybe dozens of megabytes sitting around their disk space. Once you start talking about, you know, 1 gigabyte, 10 gigabyte models, and you're doing that over and over again, it becomes much more problematic.
But reflects poorly on.
Yeah.
Yeah, permission prompts aren't great, but it does feel weird if I'm just browsing the web and, you know, 2 gigs here, 2 gigs there, 2 gigs there. So
Yeah.
if there was something that said, hey, this site wants to download a large model, and if you could give enough context about what it's about to download, they might hit allow, and maybe the second site that comes in, the dialog could say the site wants to use a large model, and by the way, it's like already here, so your incremental cost is low or zero, and there's, you know, timing side channels, but like maybe there's a prompt that's like
Exactly.
fine, right?
Yeah, I mean, I will say that like sites already can download very large amounts of data stored on your disk with no interference from the user.
Do we think that'll continue if every site downloads?
Well,
2 gig model?
so the question is, was that a mistake that we just never bothered, you know, to allow that all these years that just no one ever took advantage of? But I do think that showing some sort of like, there's really 2 problems here you described, which is the one that's been around forever, which is there's a lot of resources that are very small and we just care about like fractional load times.
Mm-hmm.
And then there's like a small number of very large resources. And I think that the solution's not going to solve both of them at the same time as easily as if you partition this space.
I have a slightly
Especially
different,
around like
There's a
privacy
hand up.
concerns.
Sorry, Thomas.
I have a slightly different perspective on this, which is that the unifying thread across all of these conversations is, does it actually hurt on a rich person's computer? Right? The reason that we're hearing about this specific class of resources is because they don't fall into the noise for people who are developers, right? And so like that's the reason that you're getting pushed here. And so the question that I'd like for us to answer is, okay, that cohort understands the problem finally, I guess. That's great. How do we expand the window so that users have material choices too, right? So if there's a question there about how do we make these things legible, sort of saying, oh, you can download a lot of stuff. I mean, that turns into a problem for high-end web applications too at the limit, because they eventually see slowness and their users tell them that things are slow. So that's the thread. How do we join them up across these different media types? And I would suggest here that maybe, I apologize I missed the beginning of this, but maybe there's something to do where we have a way for sites to describe these things as shared resources that, you know, we talked about permission prompts, but choosers, right? Choosers are a thing where we can maybe provide the ability for you to sort of put stuff into a shared storage and, you know, reflect it back with description.
So I'd like to understand better, is the capability to detect which models are available, like which resources are available immediately versus have to be downloaded, is that important versus when I first read the proposal, everything screamed to me like, this is just a browser caching kind of problem, right? Like it should be just like a cache of like, you know, the browser should just cache these resources and just, you know, make the download faster. And I get that there's a timing attack aspect to that, right? If you get a 10 gigabyte resource immediately, then obviously there has to be a cache involved. But that was just like, I thought like, oh, this has to be browser. So is the capability to actually learn about it super important?
Or I think if you look at something like how Transformers.js would denote this, I think it would be very useful for Transformers.js to know what are my locally 'installed list of models. whether or not you just hand every website who wants it, either through a permission prompt or some other mechanism, a list of all the locally available cached resources, or whether or not you let them try to kind of fetch it. I don't know the trade-offs there. I guess thinking it through, if the site is malicious and just wants to test loading everything, then they would get that information regardless. So why not just give them a list and simplify it? Maybe forcing them to pay that download cost or forcing them to pay that bandwidth usage is part of the deterrent there. I don't know.
And I don't think it has to be like overly broad where I want to know all the models available, because if you look at what Transformer does is it starts with a use case. You can see on the slide automatic speech recognition.
Yeah.
So you could just kind of do that, right? And I think it could be an easy way to explain to user what's going on and let them decide whether or not they want to let that website check the list of like models that can do speech recognition.
Yeah, exactly.
And with that knowledge, I would be much happier.
And we also played around with like, could the developer provide some string to say what they wanted the model for, what they thought the model did? But of course, letting developers provide anything that shows up to users is recipe for disaster as well.
Yeah, I might make it overly complex and not actually improve the situation much.
Yeah.
But you can imagine something where instead of querying, you can define some set of constraints and preferences. And if some of that needs to plug into some dialogue that says, hey, developer wants to use a shared model, but they're also offering, higher quality results. If you pick the non-shared one, you, the user, make a choice. I don't know. And, you could rate limit potentially.
Yeah.
Like, you can't list 1,000 models on the constraints. You must like up to 5 or 10, and you can make one of these or 3 of these queries every minute.
Yeah.
That goes to the point of a picker. I'm not sure personally. I mean, maybe I'm an outlier, but I'm not sure I would want to pick my model for such an application. Like that feels like I would have no basis for making that choice. Honestly, I would have to do extensive research, and I don't think and I'm a technical person, right? So I'm not sure. I think also with the technology progressing, I'm not sure if that's the right basis that we're, basing the prompt on, right? I feel like maybe in 10 years or so, that or 5 years, that's going to be not even something people think about.
I would agree.
In a way that wouldn't put like their JavaScript functions people, use or something like that. So,
or pick which frameworks or something.
Right. Maybe the better analogy, right?
I just want to recognize we're 3 minutes over time for the session. I don't want anyone to miss lunch, so I'm just going to call it there. But if anyone wants to keep talking, come find me at lunch. We can powwow.